Ladies and gentlemen, in this video I'll be describing the process of designing your concrete mix. So some of the learning outcomes associated with the video, we're going to understand what the design of normal concrete process is like, and then I'm going to have a look at the actual design of the mix in accordance with the Building Research Establishment, which is a set of guidelines from the UK. So let's start by looking at a set of definitions. The definition of a concrete mix design. What is a concrete mix design? When you talk about a mix design in concrete, you're basically asking the designer to select and proportion the constituents to end up with your final concrete product. So the concrete mixes would be designed so that they have a specific workability associated with the concrete mix, a specific strength as specified by your client, and also the concrete mix has to ensure that the final product would lead to a durable structure. When it comes to the selection and the proportioning of materials, there's a number of factors that this selection process would depend on. So number one is the structural strength that has been specified by the client. Number two is any environmental factors associated with the location of the project. And for instance, over here we're talking about the climate of the project. Is it a hot climate? Is it a cold climate? What are the available resources as well within that region? Number three is the job site conditions. So how easy is it going to be for us to pour the concrete? If you're dealing with a high-rise building, for instance, then you might face an issue when it comes to pumping concrete to your 10th story. So from the ground level to the 10th story, and that's where you need workable concrete. So you have to consider that in your concrete mix design. And then finally, the characteristics of the available raw materials. So for instance, the texture of your aggregates. The content of water that's contained in aggregates, how is this going to impact your overall water to cement ratio in your concrete mix? So these are certain factors that a designer would have to have in mind before they initiate the mix design process. So in a concrete mix design, there are several parameters that would be associated with the design process. Number one is the compressive strength of the concrete. So what determines the compressive strength is mostly, number one, your cement, and number two, your aggregates as well. The second parameter that you'd have to look at when it comes to concrete mix design is the workability. So this has to be determined again by the client, and subject to these requirements, you'll have the water to cement ratio determined. And then also the type of aggregates. So how are the aggregates classified? Are they sort of how much of it is coarse versus how much of it is fine? So the method that we're going to go through is based on the British Building Research Establishment guidelines. It's an easy set of guidelines that's commonly adopted in many countries around the world. So what are the inputs and outputs associated with the concrete mix design method? So the overall process involved in normal concrete mix design, you can think of the process as comprising 5 main stages. Stage number one is associated with determining the water to cement ratio. To determine the water to cement ratio in stage number one, the designer would have to specify the required strength, and you obtain that strength from your client. Stage number two then is where you use the input of workability to get the water content in the mix. So workability would have to be provided again by your client, and based on the desired workability level, you would get the water content that would be used in the concrete mix. Stage number three is then the combination of stages number 1 and 2, and that would yield the cement content. And then stage number 4, you would determine the aggregate content in the mix. And then finally, stage number 5 is associated with categorizing the content of aggregates in stage number 4 into fine and coarse aggregates. In terms of input data, and this is input data that you would need at any of these stages that I previously described, you need your characteristic compressive strength, so this has to be provided, as I said, by the client, the minimum or the maximum water to cement ratio that the client would accept for the project, the minimum cement content, the slump level, and the maximum aggregate size that the client desires to use in the concrete mix. Some additional input data that the designer should be aware of includes the aggregate types that would be utilized in the concrete mix, the aggregate density as well, looking at how fine your aggregates are, and then finally some data on the compressive strength for certain samples of concrete that you would take. Now this sampling process is essential because, as you are all aware, cement is produced in a process that I have described in a previous video. There's some sort of quality assurance that has to follow through the process. And quality assurance is required because you can never be consistent with the production of the material itself. So the material can never have consistent properties. So to combat this issue, what we do is we try to sample some of these concrete mix and make sure that it's within a satisfactory level, and when it comes to compressive strength. Now likewise, a defective rate, a maximum defective rate would have to be specified to make sure that there's only a small number of samples that do not comply with the required strength. An example of an output that you would get from your concrete mix design, and you can see that on the screen in front of you. So here we have the cement, the water, the fine aggregates, the coarse aggregates type number 1 and the coarse aggregates type number 2. Each one is associated with kilograms per meter cubed content. And that is a result of the mix design process. Now, aggregates 1 and 2, these are just some random types that I just use for demonstration purposes. But typically, you would have, these types would be classified, say, for instance, according to whether you're going to be using aggregates of particular sizes or aggregates of particular densities.